Welcome guys, Sizwe Sakhe here, Sizwe Sakhe Academy, and this is the Global Classroom. Guys, still on trigonometry. Now we just want to show the table of, it's a table of degrees, radians, the y value and the decimal, which means the y value is the sine theta, the sine value, but the y value we are taking the y value, it's sine theta, but on spatial angles, on ratios, and then we put it in a decimal form here. We put a decimal form here. So let's start. The radians. The radians, it's 0. Radians, it's 0 degrees. It's 0. Remember, the radians is 0. 360 degrees, sorry, not 360 degrees, 30 degrees, we had pi over 6. Oh, let me make my 6 visible. At 45, we had pi over 4. These lines are just trying to show so that I put it in a straight line. It doesn't mix up and twist, and the other one being the value of the other incorrectly. 60 degrees is pi over 3. At 90 is pi over 2. Let's try to keep it this side. Pi over 2. At 120 we had 2 pi over a 3. At 135 we had 3 pi over 4. 3 pi over 4 at 135. Maybe let me just to add so that you can see where which is going. You see this one starting to stray. Let's put it like this so that you can see nicely. This is 5 pi over a 6, and at 180 we had what? A pi, straight pi. 210, 7 pi over a 6, 7 pi over 6. At 225 we had 5 pi over a 4. At 245 we had 4 pi over 3. 4 pi over 3. At 270, what did we have? We had 3 pi. At 270 we had 3 pi over 2. You see? Oh no. Maybe let me correct my lines nicely, to put my lines nicely. Try my best that my lines are correctly placed, though it's going to deviate a little because now I'm trying to make a straight line so that it reaches. Let me give this one a little bit of space. So at 300 we have 5 pi, 5 pi over 3. 5 pi all over a 3. Let's confirm that with a calculator, but I do believe it's 180 times a 5 is equal to, divided by 3 is 300. Yes, 5 pi over 3 at 300, and 315 would be 7 pi over a 4. Yes, over a 4. 7 pi over 4. Because of space, guys, please do allow me to further maybe let me take both these 330 a little lower, 330 degrees, 360 degrees. Here at 330 degrees, we will have 11 pi over 6. At 360 degrees, we will have, I'll just write it here because of space. I'll bring it closer to the 360. It's a 2 pi, maybe it will fit here, but let me put it here, 2 pi. 360 is 2 pi, 330 is 11 pi over 6. This is not minus. Maybe let me reduce a little before we say minus. No, it's not a minus. It's just my way of putting it straight. Maybe let me wipe it off from before we say it's negative. It's not negative. I'm not putting it in any negative format. I just want to put it in radians. I'm putting it in radians. So at 0 degrees it's 0 radians, 30 degrees it's pi over 6 radians, 45 degrees pi over 4 radians, 60 degrees pi over 3 radians, 90 degrees is pi over 2, 120 is 2 pi over 3 radians, 135 is 3 pi over 4 radians, 150 degrees is 5 pi over 6 radians, 180 is pi, 210 7 pi over 6 radians, 225 degrees 5 pi over 4, 240 is 4 pi over 3, 270 is 3 pi over 2, 300 is 5 pi over 3, almost said 5 power, 5 pi over 3. At 315 degrees is 7 pi over 4, at 330 degrees 11 pi over 6, at 360 degrees it will be 2 pi. Right, what I want to do now is to move to the y values. I'm trying just to get it straight. I'm trying my best with what I've got just to make it straight. Zoop, 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 zoop. Okay, so at 0 degrees radians are 0, and the y value, remember in the special angles, y at 0, x is 1, y is 0. So we have 0 here. At 30 degrees we had what? Our y value is a half. At 45 degrees our y value is root 2 over 2. Remember, 90 to 0, they are all positive, so it's positive. At 60, y value is root 3 over 2. At 90 degrees our y value was 1, because y is 1 and x is 0, so we have 1 here. From here it goes back in reverse, just trying to let you know how it works. 120 is root 3 over 2. Remember, y, which is sine, is positive in the first quadrant. This is the first quadrant, and also in the second quadrant. So at 120 it's root 3 over 2. At 135 it's root 2 over 2. We're just going back like this. At 150 it is a half. At 180 y is 0. Remember, on the straight line 180, x is minus 1, y is 0. So we've come to the point above the x-axis where y is positive. Now we're looking at y from 180 now going down. It becomes what? Negative. So it's negative half here. Negative root 2 over 2. negative root 3. Oh, maybe let me change my negatives here to make them clear so that you see it's negative, because it looks like I'm still stretching my dotted lines, which I'm definitely not at this time. My line seems to be going that way, but I'll try my best to bring it here. So it's negative root 3 over 2 and a negative at 270. Y is negative 1. Negative 1. Right. So at 270 it's negative. From 270, basically if this was a graph, this would be like this. Just want to show you. It would be like this. From here up to here, this is 180 degrees, right? From here to here, it's below. Maybe let me shorten it because of space. Let me shorten my graph. Right. Let me say this would be it. And here is 180 degrees. It's 180 degrees here where it reaches 0. You see, it reached 0 at 180 degrees. All along it was above. From 180 going down, it's negative. It goes like this from negative. Now we've reached 270. Here is our 270, which is a negative 1. Negative 1. From here at negative 1, it starts going up. It starts going up, but it's still on the negative. It's still, don't be confused by it going up. It is indeed going up, but on the negative values. So it will be a negative root 3 over 2, which is point, remember, in decimal forms, 0.866, comes back to root 2 over 2, which is point negative as well, 0.707, and then it goes back to a negative half now, here at half, which is negative. Here it's 330, half, which is negative at 330, and at 360 it goes back from negative half, it goes back to 0. This is 0 here at the bottom, and right at 360 it goes back to 0, as it would do in our complete graph. It would do. It's still on the negative. At 180, below 180 it became negative, and it went up right up to a 360. From here, you can see from here to here, it is below this line. It's on the negative y values, negative y. So it taking all the negative y values right down from 180 right up to 360, it's negative. From 0 up to 180 here, 0 up to 180, it is positive. It's negative. So this is what it does, the graph. I'm showing you what the graph will do, though we haven't done graphs yet, but I'm just trying to give you a clear picture using this table. We're dealing with the sine graph. This would be what we call a sine graph, sine theta graph. This would be a sine of theta graph, sine theta graph, sine theta. We're using y. Remember, we're using y values, therefore sine is the y value. So it's y, it's going up there, down like this, up to 0 degrees. This is -1 of the graph. Don't confuse it with the y values. It's just the negative part of y. This one, let me put -y. Yes, this would have been -1. At -1, it's a 240. Sorry, it's a 270. At -1, it's 270. This is where -1, and then it starts going up again using these values, but they're still negative because it's still below the x values, where y is negative, until it reaches 360. So this is what it looks like. This is what the graph would look like. It becomes simpler when you understand this. You know how your graph will look like, how it is shaped like. It becomes clearer. So let me wipe this out because I need to write down the decimal form now and then finish with this part. And for me to finish with this part, I need a different color pen where the decimal, since it's 0, it remains 0. Decimal form 0 is 0. In decimal form, in whole numbers, there is no point 0, 0, 0, 0 to make a 0, it's just 0. Here at 30 degree, the 30 degree, the y value is half, and it is therefore 0.5. At 45, it is 0.707, taking 3 to 3 decimal places. At 60, it is 0.866. At 1, it remains 1. Here it changes because, oh no, it doesn't, it's still the same 1. At 120, it's 0.866. At 135, it's 0.707. It just goes back up. At 150, it is 0.5. At 180, it is 0. There's no decimal point of 0. It's 0. At 210, it changes. It takes the negative form, so it becomes negative 0.5. At 225, it's negative 0.707. At 240, it's negative 0.866. At 270, it is negative 1. At 300, it's negative 0.866. It just goes like this and it reverses. It's never more than 1. It's 1 and below, right up to 0, and goes back negative 0.866 and negative 0.707, and then it goes back 330. It would be negative 0.5, and then at 360 degrees, which is 2 pi, it would be a complete 0. So yeah, this is what it is. This is what it looks like. Let me take this away just so that you have a clear picture, that I ain't hiding anything from you. This is what it is. This is what we had in the unit circle. There was a circle. Check the previous video, the other video where we explained radians, degrees, and y, but we use a circle where we explain all these angles in a circle from 0 degrees to 360, the radians, the y value, and its decimal form. Maybe I could put the x value, but once you put the x value, even these change, because not the values but the signs do change, because the graph is a bit different. It doesn't look the same exactly as the y. But I thought, and it's a different graph anyway, it's a cos graph. Once I put x here, it becomes cos. This is sine. So I wanted to show you table. Maybe let me put it up there. The table of the sine graph. Sine theta, because here our degrees in theta form, theta graph. Maybe that's the proper way of, it's a table of sine theta graph. Just the table, it's not the graph. I did show you a little bit, a hint on the graph of the y or sine theta, how it looks like, but this is the total table. The degrees, 0 to 360 degrees, radians 0 to 2 pi, y from 0 back to 0 here in ratios, 0.5, halves, root 2 over 2, root 3 over 2. This is what it is. And the decimal 1. This is what it is. These are the decimal values of that graph. It just gives you a clear picture of what the sine graph looks like. These are the values you'd have to use to table out that sine graph. These are the y values. Just that these are the decimal values, point form values, decimal form. This is the degree form. So the x value is 0, 30, 45. That's the x line in degrees term. But the y takes this form at 0, half, root 2 over 2, root 3 over 2, 1, root 3, and then gets to a negative, which is below the x-axis, and this is it. Thank you guys. Hope this makes sense. We'll now do the cost graph. Check for it so that you see the differences. Thank you. God bless you.